everyone. Thanks for joining. Today, we're going to go over our approach to high performance sustainability. And the kind of caveat here is not performative. And what we mean by that is there's a lot of conversation around what sustainability is within building science and housing, and who gets to determine whether a building is sustainable or not. And so generally we find that a lot of sustainability practices are not all that holistic, and they're a little bit of a vanity project that kind of chasing after like a full net zero or full passive house designation, which sometimes we are, but what we're going to go over is how do we bake in sustainability into all of our practices rather than chasing after a designation on its own. So your guides for today are going to be myself, Wayne, Hutz's founder and CEO, and also we're lucky to be joined by Joe Brookover, who's our studio director. And so we'll dive right in. But like I said, much of the conversation today around sustainability in housing is kind of focused on flashy things and shiny objects, particularly technology, that there's a notion that a building or house can become sustainable if only you bolt on solar panels, if only you incorporate geothermal, if only you utilize battery walls or other very visible technologies. And while those are an important part of a program for us, high performance sustainability is really the result of a series of decisions and not just the starting point. And so we think a lot about arriving to sustainable outcomes by pursuing a specific order of functions. So we really think about what do we need to do first within the shell of the building and the envelope of the building, then siting, then specifications, and then kind of technology last. So a lot of our approaches to sustainability, I would say, are hidden or unseen. And so today we want to reveal some of those. Like I led at the beginning, I always make this distinction between capital P passive house designations and passive principles. So we are occasionally pursuing full passive house designations in our projects, but not letting some other people in here. There we go. But not always, and we don't always see the pursuit of that designation as us having realized a sustainable outcome. And so one of the things that you find is that those certifications tend to add cost, a decent amount of administrative complexity, and the performance improvements might be minimal, but the downstream costs of how like a contractor views the construction, what the level of inspections and reviews you may need to go through to achieve that designation may or may not come with the right kind of cost benefit. And so for us, we really prioritize practical and cost-effective building performance over the achievement of trophies or certifications. So we're going to go over the four tactics and the sequence that we think about, with the first being on the shell and envelope. And our standard designs or our standards are really the starting point for so much of our sustainability practices. And that baked into our core product, our standards, is a lot of the heavy lifting for achieving high performance results. The next is siting. We're a rural development practice. The relationship to the land, the relationship to sun path, the relationship to wind, and kind of prevailing natural conditions is both a design choice. How are we thinking about relationship between built space and landscape? But it's also a sustainability practice. How do we take advantage of solar gain? How do we take advantage of prevailing winds? How do we take advantage of natural ventilation? And you have that opportunity to do that in wider rural lots in the way that, say, in like an infill setting or dense urban setting, you kind of don't. The lot's going to be what it is. But out in the country, we can reorient things, we can rotate it, we can place structures in different orientations to get better performance and sustainability outcomes. The next is equipment. How do we right size our systems? And once we know the building shape, once we know the siting, how do we look at our heating, cooling, appliances. And then last, really, for us is our generation technologies. Where's our power coming from? How are we layering in some of those very visible technology components, and how do we choose them and when do we choose them? We're also going to look through the lens of a couple of real world projects. In particular, our Blueberry Hill ADU, our Churchtown Road project, Blueberry Hill House, Bait Road, and Queens Highway, all of which you can find on the portfolio section, huts.com. And we'll also share this presentation with everyone who attended today, so you can click right through to those projects and see them directly. But let's start with the shell and envelope, and I'll just set this up, and then Joe, I'll pass it to you, and you
Yep.
let me know when to advance. But like I said, the building assembly for our standards does a lot of the heavy lifting for us on sustainability practices, baked directly into what I would call our core product, our standards, which is both our home plans, like the Village or Big L or Small Bar, or whichever kind of standard plan you're drawn to. Those are really, in my mind, the standards are a set of building assemblies and components and construction logic. And baked into those are the ways that we detail buildings, the way that we think about the building science and construction techniques, regardless of the format that they turn into, whether they are more L-shaped or village shaped or bar shaped. The wall assemblies, the roof assemblies, and the ways the buildings come together to operate as a high performance envelope are standardized across the board. And so one other note here is that a building shell is kind of only as good as its ability to be assembled well. You could have a great kind of wall in one direction and then a wall on the other side, but the meeting point is wide open, or if we don't have a way to kind of close it up tightly, then you're gonna have the same issues as if the it was sort of a cheap assembly from the beginning. And one of the ways that we sort of guarantee that the assembly is going to work well is that we make the assemblies quite simple. We're working on rural projects all over the country with lots of flavors of contractors in rural settings. And we've worked quite hard in our standards to simplify the detailing so that we're putting a building system in the hands of contractors with all variable skill sets. And so we need to make sure that we met them at sort of like the lowest common denominator abilities so that it'd be very hard to assemble a hut shell and really mess it up or have it be that it's wide open or not the sort of like airtight assembly that we have in mind. The other thing that I would mention is that our building assemblies and the building logic of our standards is not strictly stick built, not strictly panelized, not strictly prefab, but is actually meant to be built in any number of those formats. And done well, we don't see like a huge difference in the performance when it's a hut standard site built or it's a hut standard that we brought on one of our panelization or prefab partners for, because it's the same underlying logic. It's just really where is the assembly happening? Is it happening in the field or is it happening in a factory? But in all cases, our standard shell is meant to be executed both site built or prefabbed, and we make those decisions somewhat on pricing, somewhat based on labor availability, somewhat based on location. So, Joe, I'm gonna pass it
Yep.
to you here, and then I'll advance through.
Yep. So if anyone who's not familiar, this is kind of a little bit of a sampling of our standard plans across various sizes of our projects. And like Wayne was saying, although these are different sizes, different configurations, when we go through particular projects, we come up with different forms that are suited for the site. A lot of the principles of how the foundation, the walls, the roof, how those are working are all consistent throughout, making sure that we're I think that the most important thing that Wayne said is that we're dealing with a lot of contractors in a lot of rural environments, some that aren't necessarily up on the latest building and science. There's a little bit of an education we go through with them. But but making sure that we're designing things from the start that can be built anywhere, that use common off-the-shelf materials that are available very widely and aren't blowing the budget to try to achieve a certain level of performance and can be executed really well, is really important about how we go about like the bones of these standards and these designs. If we go to the next slide, you can see a little bit of examples of this. All good. So one of our projects, Blueberry Hill House, this is an example of a project that is approaching and is meeting passive standard. I don't know if we're going to get certified or not, but this is a completely stick-built project. It's using off-the-shelf standard dimensional lumber, trusses that are manufactured locally and brought to the site, and just being very intentional around our air sealing, our thermal properties, and our vapor control. Those are really the three sort of essences of building a good shell, and our detailing accounts for a lot of that. So you see, like, again, very typical framing members that you can find anywhere in the US, that every single house in the US is built with. But we're, finding really great ways to improve things through like smart vapor barriers, through understanding how we're running chases for ductwork and electrical and things like that in ways that aren't penetrating the building envelope, and finding ways to compromise how that shell needs to perform, and using materials such as blown-in cellulose or others that don't have the susceptibility to mold over time if there's vapor issues or if there's moisture issues within the project. But again, all of these things aren't, as it's not rocket science. It's not really expensive things to make these happen and perform really well. They're all things that you can find pretty much in any market, any rural market across the US. If we go to the next slide, this is an example of a project under construction right now, Bait Road. Still using all the same principles, same form factors, all of that, but the shell, all the framing that you see here are prefabricated panels. So they're fabricated within a climate controlled warehouse, they're shipped to site, and the frame of the building goes up over the course of 2 or 3 days. Of course, that's excellent from like a construction timeline perspective. Like something that could take a few weeks is happening in 3 days. But the quality control on the integrity of that envelope is really improved, and there's less susceptibility to like something raining midway through the project being built and having worries about there being like mold or water damage within the framing over time that may not properly have dried out. So again, same standards, same fundamental approach, just a different way that you can create that shell that has some additional benefits. And the last one is that there are some projects where we work on some things that are really on the leading edge of panelization or modular. This is an example of a straw panel, densely packed straw. A really cool product, highly sustainable. There's more work involved from like shop drawing review and fabrication techniques that we're making sure is well coordinated. But there's a lot of these type of products that are out there, and our form factors and our standards really allow us to experiment with different types of highly sustainable building envelopes that are hitting the market in various ways. Again, because we don't have complex detailing, we have really simple ways for these things to be executed well, which really lowers risk of going something that may be a little bit of a leading edge of the market from a panel or a shell perspective. Want to keep going, Wayne, or do you want to lead in?
Unmute. Yeah, let's keep going. I think that the most important thing to take away from the building assemblies, and obviously we've got a huge catalog of detailing for every single condition, every roof condition, every wall condition, all kinds of manufacturers that we might insert into the shell, whether that's doors or windows or other glazing techniques. But the most important thing that we're trying to get to in the shell is something that's airtight, well insulated, and not leaky, because ultimately, no matter what you do on the power generation side or on the technology side, it's all going to be kind of for naught if the building is letting all of that out. If all the heat that you're trying to capture is now exiting through a poorly executed shell, or all of the cooling that you're bringing in is now exiting through a poorly insulated shell. And so for us, there's just no place to start here other than making sure that the envelope is airtight, highly insulated. And what's nice is that a lot of our standards were developed in initially quite extreme Northeast environments. And so when we go to more temperate locations, we're sort of blowing past any blowing past code, certainly, and really getting into that kind of like near passive territory.
Yeah. Yeah, I'd say it's a good point, Wayne. Like our base level and all of our standards really exceeds what's required from code pretty much anywhere in the US. There's a few, New York is catching up pretty quickly and is like leading the way on actually on building codes and understanding good building science and how envelopes need to be built. But yeah, to Wayne's point, because we got started in upstate New York with the majority of our projects, a lot of that code thinking and the baseline standard for how we know to create a really well-performing building is now applying to a lot of more far-flung places that are many years behind from a building code perspective. So that's kind of, yeah, that's a benefit of having some really cool areas where we get to do these test cases, but then being able to build all over the US is that we can really leverage the best like techniques, the best approaches from very diverse areas within the US and apply that sort of anywhere.
Right. So, you know, assuming we hit the mark on our building shell and 75% of the heavy lifting on pursuing passive principles and sustainable practices have happened. Now we're starting to tune that design to the site. And we're lucky at Huts that we get to work on projects with all different kinds of landscape conditions, whether it's seaside or mountains or meadows or sunny places or rainy places. But all of those come with innate characteristics and innate conditions that let us sort of fine tune how that envelope is performing based on the local climate.
Yes, this is an image here again of the Bait Road a project, but some of the principles that we really try to meet when we're thinking about sustainable site planning, it's how we minimize site disturbance. We're not just clear cutting half an acre to make the project fit, but we're being really thoughtful about the existing topography, the existing trees, where things need to go, the area the contractor needs to actually build the house, but we're working with the contractor really early on to make sure that we're limiting the amount of clearing, the amount of disturbance that we're impacting on the site. But then from like a broader site perspective, like we're always looking at sun angles and sun position throughout the course of the day and the course of the year to orient the project depending on the climate condition to take advantage of the sun or try to shade from the sun or really tune it for solar generation. And also having the ability to adjust things like the foundation or the roof for certain climates. If we're in something that has a very heavy snow load and we need to have roof eaves, for example, or we're building foundations in such a way that minimize the amount of excavation and the amount of material that we need to use. Those are all things that come into play when we're thinking about siting and what siting means for our projects. Yeah, one thing we do is like, again, this is Fate Road, and we are going to have solar on the roof for this project. After we got a good way through the design, and the contractor, we engaged a solar company that's going to be installing these panels and work with them to provide a solar analysis of like what is the best orientation of this project to really maximize solar gain throughout the course of the year. And that resulted in about like a 20-degree shift or rotation of the foundation for how we originally designed it to make sure we're really tuning in for solar. But we always prioritize those type of conversations, remain flexible and not sort of locked in to what a project needs to be if it's sort of pushing against optimizing things like solar that this client was really interested in. And yeah, we're going to achieve a really excellent result for this. Yeah, thinking about foundations, as Wayne was saying, sometimes like we're building a really flat site, sometimes we're building on the sides of the hill, but always taking the land for what it is and not trying to force a project into it or force a building onto it. We love the idea of being light on the land, which is like exemplified here in the Blueberry Hill AU, where it's kind of on the side of a bit of a rocky slope. There's a small stream down below. So this whole thing sits on piers. We didn't excavate into the land. We didn't have a lot of disturbance or soil running everywhere. We're not trying to get a concrete truck in before the foundation, really minimizing the machinery that's going back here and the type of foundation for the project. And lastly, this is the Blueberry Hill house. We worked with a contractor here to do a little bit of a different type of foundation approach, which is called a shallow slab, but it's highly insulated with a lot of insulation. So this is upstate New York. Typically, you're building like a footing that's 50 inches into the ground, like about 4 feet. A lot of excavation, a lot of concrete, like embedded carbon within those types of materials. And what we're resulting in here is like a foundation, probably like 25% of the concrete you normally would need to use for a typical type of foundation, and a whole lot less excavation and site disturbance. But something that is much higher performing because we're achieving really great R values for this. So we're able to get a concrete slab in a cold environment that's not going to feel cold, all while minimizing the amount of material on site disturbances happening for the project. It's a pretty cool result. Let me keep going, Wayne. Let me just go through them. Great.
Yeah, you're good.
So yeah, mechanicals are sort of the next step. So after we're feeling really good about our shell, we understand how we're hitting the land, that we have the project oriented the right way. We start to get into the bones of the project. When we're thinking about mechanicals, of course, the system matters, but the orientation, the amount of heat gain a project is taking matters, and the size and the volume of the project matters as well. So we're not building or designing houses that are oversized from what might be required. We're building just enough space to have a really great house. So we're right sizing the space for the use, and we're able to really right size and design the mechanical system for the spaces of the actual house that we're using. What may not be known is like a lot of ways in which mechanical systems go into houses across the US is that contractors just have a rule of thumb. Oh yeah, this thing is 3,000 square foot, so I'm going to design something for a 4,500 square foot house, over design it, make sure I have enough heat and air pumping in there. The clients are never going to complain about comfortability. They also do that because the shell is questionable. Is this thing airtight? Is like my heating and my cooling leaking all over the place? In that case, I do need to bump this up even a little bit more to account for that poor construction right off the start. But again, like building on our previous things that we talked to, we trust our shell. We know it's good. It's easy to execute. We're sizing the house appropriately, kind of based on our starting point for our standards. We're siting it well. We're able to have a lot of confidence in how we're designing the mechanical system for that house. We're not oversizing it. We're not just using rule of thumbs for how this gets done, but it's being very particular for each location, for each size of space. So if we go to the next slide, a few ways in which these are examples of images from our Churchtown Road project. This one is utilizing geothermal for the heating and cooling, and on the right, you see the small mechanical basement that we put into this project to handle all of that equipment, all the tubing that's going to be supplying that. But because like we're right sizing the houses and we're planning for a couple different ways that mechanical systems can go in, we have a lot of options available to us. A lot of projects all of our projects are all electric. We're always doing all electric mechanical. That's becoming code in a lot of areas as well. But we're able to accommodate ducted systems, that have your traditional vents that you're used to seeing, or having mini splits that are heating or cooling multiple spaces. We care a lot about like the routing and the ducting of mechanical systems when we're working through that on projects. It's important from an aesthetic perspective of like where the vents are and things like that. But there's ways to do it well from a comfortability perspective of where you're supplying that air or not supplying that air, which also helps with efficiency. And something that's very standard in a lot of our projects too is an ERV or an HRV, which is like a more technical term for a portion of a mechanical system, but is required to create fresh air within a building that is very tight that we're designing, and really helps with the efficiency of the system. And this is a cool little thing for the Blueberry Hill ADU as well. We do work on projects that are interested in being completely off-grid. This is a little structure we designed for that ADU that houses everything, separate structure that houses everything that ADU needs. It has solar and battery storage. It has rainwater catchment and storage, which supplies all the fresh water to the project. And the project is able to be completely off-grid because of this unit here. It's another thing that's interesting about this, not shown here. Again, it's a separate structure that's located a little bit farther away, at maybe like 80 yards or so from the house. But again, that allowed us to, not be bringing heavy equipment into where we're building that small little cabin, allowing that thing to really sit in the trees and be respectful of the site, because we were taking some more high impact things and situating it farther away from the site. So thinking about distribution of utilities, how that impacts the land, was also an important aspect of that. More specific example are a couple of images here, which are pretty interesting for Churchtown Road. These clients had an existing house, an old home, had a lot of moisture issues in the basement, as like a lot of old homes do, and unfortunately some new homes do as well. So they were really keen on not having any basement within this house and doing something that was completely slab on grade. So we were able to accommodate that while still just creating a very small basement and mechanical room on this building that didn't take up ground floor square footage, but honored a lot of the intent that the client wanted to reach on how do you minimize issues of mold or moisture over time as we're thinking about being healthy in the building, having healthy air, and having healthy spaces that we're living in.
But really, I think what's important here is if you think through that sequence, we've got a tight shell that isn't going to waste energy, waste heat, release heating and cooling. We've got siting that's kind of fine tuning that shell based on how are we meeting the land, how are we orienting to the sun path, how are we utilizing interesting tactics in our foundation approaches, and how are we being light on the land. And then how are we including mechanical systems that are appropriately sized, both for the level of efficiency of the building, but also the size of the building, that our standards tend to not be huge houses, that we're being thoughtful around the overall square footage. And so generally that gives you less to heat and cool, and it kind of sips energy overall. After that, there's sort of like additional sustainability considerations. So then we're thinking about the generation technologies. Are we going to have a solar array? Are we going to incorporate geothermal? That there's a relationship there with siting, but we tend not to. We even size those systems based on what the generation requirements are going to be. And there's things like operational home systems or operational technologies. How are we making sure that there's smart home systems that are integrated? That's particularly important for second homes, guest houses, places where it's not always in use. How are we bringing the energy usage up and down and doing that sort of automatically? And then the last, you can call it an upgrade, but it's really something that we're always sort of dedicated to through our standards and through our specifications, local sourcing. How do we make sure that all of our raw construction materials and all of our fabricated and manufactured goods are coming from within like a day's drive, and that just the embedded carbon in those products is limited because they're local. And our specifications are based on aesthetics and costs, but also region. And we have to always be building out those vendor relationships because we are working all over the country to make sure that we can actually be local and make that true. So I'm going to land here, and then I do think we're going to get kicked off in a minute, and then I'm going to come back onto the same link for Q&A. But I think that this is an important image, or maybe like kind of the crux of the conversation here, that we think about this not as just a smattering of sustainable things you can do, but a sequence where we're saying big chunk, good, like big chunk of this is taken care of by just the quality of the building. And then everything after that's a little bit incremental, and we arrive at this point of being able to decide on our generation techniques and arrive at the kind of target R values or target usage goals that we have. Well, Joe, any final thoughts before we open up to Q&A?
I don't think so.
Cool. We lost some folks, but there's some brave soldiers left. Please do share your questions here. I saw one that Christine had written in asking if we ever work with landscape architects on our projects. Yeah, for sure. Sometimes, particularly on larger like hospitality projects, there's like a more involved landscape component. We think a lot about master planning and siting and the design of like outdoor rooms and outdoor experiences, but our strength is not necessarily in planting plans. Often we need to coordinate too with civils, thinking about retainage and walkways and how are we going to tier and layer the land. But it's many of our projects are single family residential, and there isn't always that budget for all of those various folks. And part of our premise is that we're getting these single family residential projects done in rural areas at more approachable pricing. And a part of that is being thoughtful around which consultants to bring in. You can, if you have anyone here, small enough group, you can unmute and ask a question. Otherwise, you can put it up in the chat. Going once, going twice. Here we go. Meredith asks, building with these sustainable systems in mind is more expensive than traditional building as I try to get my partner on board with going this direction. Are there studies that show the long-term savings? I mean, I think that that's kind of the point of this whole presentation is that it doesn't have to be. That, yes, there are certainly cheaper building types that are like right on the edge of code compliance. And you see this with a lot of kind of mass home builders like the Pulte Homes of the world or Point Two Homes of the world. Like their houses are right on the edge of what the code even allows for. And nowhere past that. And they're looking to build kind of as expensively as possible. I would say that our price points are at a spot that is certainly more than the cheapest home possible, sort of mid-tier cost overall on residential construction, but with a high enough performance that you have meaningful savings on your heating, cooling, and management costs. It is a good case study that I do think we'll put together, Meredith, looking at houses that have been completed for a few years, say, and going back to some of our clients and asking, open up the books. Let's see what the power bills look like. Let's see what your heating and cooling costs look like, and compare it to prevailing in the area for traditional construction.
I think there's also like when we're asking like those type of questions, Meredith, there's like some awesome like let's call them side effects or of building something that is more sustainable or well built or a better envelope than maybe traditional building is like your indoor air quality is a lot higher. You're not getting allergens, you're not getting if you're near a roadway, the pollutants that are in the air, they aren't coming in being sucked into the home like something would otherwise. You're not having moisture issues within your wall cavity that could lead to mold or mildew over time. Humidity in your house is better controlled for comfort. There's less insects that get inside of the house over time because the shell is really well built. So there's like just building a good shell, like it's really good. It's like advantageous for like utility costs on the line, but it's also really great quality of life things that happen along the way, just from a comfort perspective, and an air quality perspective that are maybe not as measurable as just what's my cost per square foot I should build.
Yep. And you wrote more specifically on solar and geothermal. So solar and geothermal definitely have long kind of payback periods on if you're comparing them to just like on-grid systems, how long is it going to take relative to like a more traditional approach? But depending on the state that you're in, there tend to be still lots of subsidies and financing options for both of these technologies. Solar in particular has a really robust like a financing and subsidy program around it almost everywhere in the country. Geothermal, a little bit less so, but that's a kind of cost analysis that we tend to do on a lot of our projects is evaluating what those generation systems are going to be and whether it's going to be worth it or not based on the sizing of the system. And what is always important is that we work through the requirements of the house first, essentially by designing it, and then are able to back into like, well, how big do those systems have to be? And then it makes it a lot easier to compare it against traditional utilities pricing. Johnny asked, you mentioned about manufacturing the panels in advance before they arrive to the site for mainly quality reasons. Also mentioned most of the framing products are readily available off the shelf items. You work with a specific contractor to build the panels in advance. Yeah, so two things there. One, keeping with the idea of being within a day's drive, both for like, cabinets or like manufactured products. We think the same way about panelization and prefab partners. And so we don't have a single operator where we say this is Hutz's prefab or panel guy. We have regional partners that are within that sort of day's drive radius of our project locations. And they are also using local products, so local wood types, local materials, local labor. So we have like depending on the area. If it's the Northeast, we have kind of a group that we utilize. If it's Mid-Atlantic, kind of Blue Ridge corridor, we have a group that we work with. If you're in the Mountain West, we have a group that we work with. So no specific panelization provider, but it's sort of like a cloud of partnerships that we're always building. And I would say that all panel providers are not created equal. Some of them, their specific mandate is that they are there for performance. And so they really want to work on high sustainability buildings when we know that's part of the objective. That might be the goal. In other cases, the panelization partner is really there for speed. And they're kind of just letting us fabricate the shell in parallel with site work and concrete happening. But they're building it to our spec, so they're going to be still a high performance shell overall. Did that answer the question, Johnny? I got a thumbs up, so yes. Any others before I? Okay, great strategy and idea. Thanks, Fran. I like the fact that many of your strategies could well be used in traditional construction. Watching from Argentina, microhousing and prefab housing is becoming a trend, but not for the sake of sustainability, but just cost. We have examples made in steel framing, even concrete. Yeah, for sure. I mean, I think that you're getting to an interesting point that prefab is both term that means something and also kind of means nothing. Like it's sort of prefab is really just a thought that something is happening not on site. And what is happening, whether it's for cost, sustainability, repeatability, volume, whatever the objective is, and also what's the environment. Like sometimes you're in a temperature, climate controlled facility and components are being prefabbed. Sometimes it's like exposed airplane hangars, and it's really just for scale, lots and lots of output. And so I think the the important thing to think about with prefab, particularly if it's a tactic towards sustainability, is understanding if that's the objective of the panelization company. Like, are you doing this for volumetric scale because you're a provider to a tract home developer, or are you doing it because you're looking to get a certain performance output? And that's a type of question that we get a lot where people do very light research on, oh, I think I want to do prefab. And it's like, cool. That doesn't mean much more to us than I think I want to use a contractor or I think I want to build a place. Like it's not specific enough. So I think that the same way you might ask a contractor, how do you think about your rough carpentry and your close-in techniques and making sure that there's an airtight shell, which we would ask of every carpenter or contractor. You also need to set up a panelization company and say, in what ways are you ensuring that the execution of this building shell is going to be airtight and high performance? And is that the reason you exist, or is it for some other objective? Cool. Any others before we wind it down? These are great questions. Thank you for asking, and also thanks for coming to the second location. Someone told me in law enforcement before that if anything bad ever happens to you, like if you get abducted, to never ever go to the second location, no matter what. Don't go to the second location. So you guys broke that cardinal rule, but I'm glad you came over to this second Zoom meeting. And for the future webinars, we'll solve that problem. In the meantime, we will. This is recorded. We'll share this with the group here and anyone else that registered and wasn't able to join. We'll also share this presentation. And like I said, please feel free to reach out to Wayne at huts.com if you have additional questions or other things pop up, or if you're thinking specifically about your project. We'd always looking to work with new folks, particularly if this is part of your interests. You're thinking about how to have a well executed house that performs well without it necessarily being like a sustainability vanity project. That's a great sweet spot for us. Otherwise, we will cut it off here and we'll see everyone hopefully on the next one. Hope to hear from you soon. Have a great afternoon.
Thanks, everyone.
Thanks, guys.